Hello everyone, and welcome to my channel, ATA Star. My name is Faye, and I'm an undergrad at the University of Oxford studying mathematics. And in this channel, I would like to share my and my friends' experience when we were once an A-level student, and how we should achieve better results in your exams, especially in math. So before we get on to any actual math problems, I think the first video I would like to talk about some things, some aspects you need to focus on as a general guidance. And the first thing I want to do is understanding of concepts. So math is different from very other subjects, okay? They were consistently introducing new definitions or concepts. In some cases, it would be rather abstract, okay? And to understand those definitions or concepts, the vital thing is you really need to understand what it means. For example, let's take one of the most important chapters in your A-level math, say integration. What is integration really? Well, some might say, well, integration is finding the area under some curve, and other people might say, well, integration is the inverse of differentiation. Of course, for the second definition, you might ask, well, what is differentiation then? Obviously, for a same concept, there are various ways to explain, but as you might see in the future, in your A-level exams, we will generally more focus on the first one. Okay, they are trying to find area under the graph. But in some cases, when we're trying to find, let's say, the solution of a differential equation, we might also want to use the second way of explaining integration. However, it is not quite helpful just to talk about it because, well, what does it actually mean to find the area under the graph? Right, so we need examples, or actual examples, and that comes to the second statement, which is practice. Well, I think it might be like everybody says, well, practice makes perfect, blah blah blah, but it's actually quite important because no one is born with the instinct in math. Like they're born to know how to do integrations and stuff. They don't. For a new concept, we need practice to get used to it, okay? Sometimes you might never understand the concept, but after repeated practicing, you understand how things work, or you will get used to how things works. So say if you see a problem, okay, very standard integration problem, and from how it looks like, you'll find a way like say, oh, I might use like integration by substitution or integration by parts. It's those instincts that builds from practice, and that really make a difference because you know, as a timed exam, we haven't got really much time to think about thoroughly about each question, how we're going to approach it. Sometimes it's one of those instincts and decide in first place in which direction you're going to solve this problem. More than saving a lot of time, they'll also help you to reduce mistakes because if you start off with the wrong direction and try to make it back to the right direction, you might make some mistakes in the process. So practice, as always. And the last thing is, what do we actually need to practice? Skills, instincts. I think these are the most important things because in A-level exams, we have a curriculum, okay? The question they're going to ask will be bounded in the curriculum, the syllabus, and from year to year, you can see the type of questions they ask are quite similar. Which means that if you're familiar with those questions, you will definitely be comfortable with in the exams, any kind of exam you will face in the future. And from my experience, because I have done quite many past paper exams, from my experience, they haven't really changed a lot of the type of questions they ask. Let's just stick with integrations. You can see there are a few types of integrations like they ask. For example, they like to ask you about trapezium rules, Okay, in the first part of the trapezium rule, so it likes to ask about evaluating the function value at particular points. And then in the second part, they ask you to use the formula to have an estimate. And the third part, they ask you to find the exact area under the graph by means of different integration techniques. And the last part, they ask you to either ask you about, well, how accurate it is, what is the error in the estimation, or they ask you about, is it an underestimate or an overestimate? Okay, you can see I'm just familiar with these questions. I know I'm expecting what kind of questions are going to be asked if I see these questions. Okay, but after all, you can see the skills haven't really changed too much. But have to be clarified that in your new syllabus, okay, after 2019, there are some new type of questions that you have never seen before. For example, once upon a time, I've seen a question basically asking you to use or take the limit of trapezium rule to help you understand what is actually integration. How is the right integration, right? So, for example, we know that integration and integration to calculate the error in the graph is basically by estimating some infinitely many fine rectangles and sum them up, right? As you can see, if you take finer and finer rectangles, your estimate will be closer and closer to the actual value. And this is the concept they actually assessed, which I haven't really seen in any past paper before 2019. But let's not worry about it too much, because generally they are still quite similar. And instincts, I've just talked about it before, okay? It's the one that gets you to the right solution quicker and more precise. And for now, I think this is all I want to say about the general direction you need to practice, or you need to remember at least, and to help you to achieve a better result in your level. And see you in the next video. Goodbye.